Gold during the classical period. The metals obtained by mining, such as silver, gold, and so on, come from water. Theophrastus. Science in the classical period was confined mostly to speculation. The pre-Aristotelians explained the origin of the universe and natural phenomena in the light of four basic elements: earth, water, air, and fire. This theory probably originated in the ancient Indus Valley civilization, was taken up by the early Babylonian natural scientists, and passed on to the early Greek philosophers, among whom Empedocles, circa 490 to 430 BC, is usually credited with refining the concepts of the theory. Aristotle embraced the four-element theory and added another concept, that of the ether. During pre-Hellenistic and Hellenistic times, gold and silver were mined extensively throughout the Mediterranean, in Asia Minor, and elsewhere in Western and Northern Europe and in Africa and Asia. A large literature exists on ancient mining in these areas, all admirably summarized and synthesized by Rickard, 1932, Davies, 1935, and Healy, 1978. Initially, it would seem from the evidence presented by many of the deposits and dumps in Egypt, the Iasian, Turkey, Anatolia, Iran, India, and contiguous regions that most of the gold came from. Alluvial and alluvial placers. Only later, as these placers approached exhaustion, were the oxidized zones of gold quartz and sulfide deposits exploited, first by open-cut methods and then by underground workings. Fire setting seems to have been widely employed by the Greeks and the Romans in underground mining. Pliny, in his Historia Naturalis, claimed that vinegar was better than water in quenching and disintegrating the hot rock. Because of water and ventilation problems, the depth of exploitation of bedrock deposits was limited, probably to 200 meters or less in most auriferous regions. Slaves and convicts did all mining. Prospecting knowledge was crude and was based principally on visual signs of the presence of gold in quartz float, in exposures in quartz outcrops, in gossans, nearby soils and weathered residuum, and in the sediments of streams and rivers. Much gophering was employed in prospecting, evidenced by an abundance of pits and shallow shafts in most of the ancient mining areas of the Aegean, Turkey, Egypt, India, Kolar, and elsewhere. The gold pan appears to have been employed for testing gossans, soils, and alluvium and for winning the metal since the earliest times. Likewise, the rocker and sluice with riffles, animal fleeces, or mats for trapping the gold seem to have been in use almost from the beginning of placer gold mining. The animal, sheep or goat, fleeces were dried and the gold was then shaken out of them into pans for further concentration. When ulex, a prickly plant of the furze or gorse family, was used, it was burned and the gold washed out of the ashes. Some placer operations employed the boulder riffle method of concentrating the gold. In this method, boulders were arranged in such a way that as the water rushed along carrying the gold, it swirled around the boulders, depositing the nuggets and dust in the slack water zones around and between the boulders. After an appropriate interval, the sluicing water was turned off or diverted to allow the cleanup. Stretches of streams with natural riffles, such as slate and schist beds and folia oriented at right angles to the stream direction, also appear to have been employed in some placer areas. In large placer operations, especially where high-level, terrace, gravels were exploited by the Romans, as along the Sil in northwestern Spain and the Verbas in Yugoslavia, hushing, booming, was employed. This method frequently required aqueducts and canals several kilometers in length. For transport of the water to the crude monitors. Where bedrock quartz deposits were exploited, the separation of the native gold from the dross, mainly quartz, was accomplished by hand-picking, followed by crushing and grinding in querns, and crude hourglass, and other types of mills, and finally by washing on sloping boards or flat rocks. These washeries can be seen in pictorial form on walls and tablets in Egyptian tombs and in a dilapidated condition in a number of ancient mining regions in Greece, Egypt, and the Middle East. Gold deposits and theories of their origin. In early classical times, ancient gold placers and mines were known on many of the Aegean islands, particularly Siphanos, in mainland Greece. Along the southern shores of Pontus Euxinus, Black Sea, and near the western coast of Asia Minor, most were small and soon worked out by the 5th century BC prospecting farther away. Particularly in the region of Mount Tiemelis, the modern Baz Dag revealed the rich electrum placers of the rivers Pactolus and Hermus, the modern Gediz. Legend has it that the Pactolus is the river in which Midas, the mythical founder of the Phrygian kingdom, on the advice of Bacchus bathed in its waters to rid himself of the fatal faculty of turning everything he touched into gold. From the Pactolus came large stores of placer gold won mainly by the Lydian kings, of whom Ardes, circa 650 BC, minted at Sardis the earliest gold coins existent. In the course of time, the Lydian monarchs became the richest princes of their age, especially Croesus, who followed Alyattes, 605–560 BC, on the throne and whose name we associate today with enormous wealth. Another source of gold described in early classical and later classical times was located in Thrace and Macedonia, where the mines at Dasauron and on Mount Pangaeus provided great wealth for Thracians, Athenians, and Philip XI of Macedonia, founder of Philippi near Mount Pangaeus. It appears that much gold also reached the Aegean area in early classical times from Egypt, Armenia, Turkey, Dacia, Romania, Hungary, and from as far as Spain, Siberia, and India. During Hellenistic times, many of the gold mines of Macedonia and Thrace were exploited intensively, as were also some of those in various auriferous regions of Asia Minor. The Ptolemies, the dynasty of Macedonian kings that ruled Egypt, 323–30 BC, prospected extensively in Egypt, Nubia, Sudan, and probably also in Arabia, winning considerable gold from these ancient mining regions. Many of the early Greek authors mention gold and silver, but without any particular geological reference. The Iliad and Odyssey of Homer, circa 1000 BC, the traditional epic poet of Greece, refer to gold and silver in numerous contexts and locations, the latter probably authentic in many cases. We have also the Greek myth of Jason and the Golden Fleece. According to this myth, the Golden Fleece was taken from the ram on which Phrixus and Helle escaped from being sacrificed. It was hung up in the grove of Ares in Colchis and recovered from King Aedes by the Argonautic expedition under Jason, with the help of the sorceress Medea, the king's daughter. In actual fact, the Argonauts were early prospectors who sought the source of the ancient placers on the Black Sea. At that time, 1200 BC, the workers of auriferous placers recovered the gold by trapping the metallic particles on sheep's fleeces placed in crude sluices. The fleeces were then hung up to dry in nearby trees and were later shaken to collect the gold. Gold is a subject touched upon by many of the classical Greek authors, but again the geological references to the precious metal are mostly vague and non-specific. Among these Greek writers we may mention Herodotus, circa 482–425 BC, author of History of the Persian Wars, Thucydides, circa 460–400 BC, author of History of the Peloponnesian War, Xenophon, circa 430–355 BC, historian, man of letters and author of many books and tracts, including De Vectigilibus, which is of some interest in the matter of mining. Plato, 428–347 BC, pupil of Socrates, renowned for his great philosophical works, of which Timaeus is of most interest to natural scientists. Aristotle, 384–322 BC, disciple of Plato. Teacher to Alexander the Great, and author of many famous philosophical treatises, of which the Meteorologica is of particular interest in the present context, and Theophrastus, 371–288 BC, of whom more details will be discussed later. Little of interest concerning gold deposits can be found in the writings of Thucydides, Xenophon, Plato, and Aristotle, although in the works of the last two there are some speculations on the origin of mineral, gold, veins. Plato's view of the origin of mineral veins is complex and far less intelligible than other aspects of his philosophy. In the Dialogue of the Timaeus, a Pythagorean view of the constitution of matter is given in which the minute particles of the four fundamental elements are considered in geometrical terms, e.g., earth a cube, air an octahedron, water an icosahedron, etc., that undergo changes, transmutations, into one another in definite ratios by resolution into triangles and reassociation of these triangles. The metals were evidently considered to be composed of various associations of fusible, water, liquid, a theory that originated with Thales. Aristotle, likewise, embraced the four-element theory of material things in the Meteorologica and considered that these elements underwent changes, or transmutations, within the earth that were actuated by the deep penetration of the sun's rays. As a result, exhalations emanated from the earth, some fiery and dry that produced stones, rocks, and others moist, watery, that gave rise to metals. One can see in these views three fundamental concepts. 1. Transmutation of the elements, especially the hope of transmuting the base metals into gold. A possibility that intrigued philosophers and particularly alchemists for centuries and that we now know to be a fact. Exemplified by the atomic transmutation of uranium into lead in the earth. 2. The dry and fiery exhalations, which constitute the basis of the magmatic theory of the formation of igneous rocks and certain mineral deposits. And 3. The moist exhalations, or hydrothermal solutions that are considered by many to give rise to most mineral veins. Herodotus, the father of history, was born in Asia Minor at Halicarnassus, a Greek city then under Persian rule. He seems to have traveled widely throughout the Empire as well as to Babylon, Egypt, Greece, Libya, Thrace, Macedonia, Scythia, and the Black Sea region. Most of his observations appear to be based on first-hand knowledge, although some of his statements are obviously derived from hearsay. None of his observations are detailed, and few give any information of geological interest. In his History of the Persian Wars, he describes the great gold deposits near Mount Pangaeus in Thrace in only one sentence. Mount Pangaeus is a great and high mountain abounding in mines of gold and silver. Theophrastus, the father of botany, has left us De Lapidibus, on stones, an important tract that is a landmark in geological science. Another tract, on mines, has unfortunately been lost. His works on the history of plants and on the causes of plants are classics in botany. Theophrastus was Aristotle's favorite pupil and his successor as head of the Lyceum, Peripados, at Athens. His observations on things mineral are acute, considering the state of science in the last half of the 4th century BC. He mentions gold in a number of contexts in De Lapidibus, an existing fragment of what was evidently a much larger work. Many translations of this fragment exist, the latest in English with an extensive commentary by Cayley and Richards, 1956. The Historia Naturalis is a great assemblage of fact, fancy, and fiction written from both observation and hearsay. Where observation prevails, the narrative is precise and logical. Where hearsay predominates, much of the text is fanciful and sometimes bizarre. Book 33 treats of the natural history of metals. And in it, the first section is reserved for gold. After a long discourse on the avarice of man for gold, the wearing of gold rings and other golden adornments, coinage, other uses of gold, and the special qualities of gold, Pliny turns to methods of discovering and mining gold ores. In the translation of Rachman, 1968, page 53. With my explanations. In parentheses we read, gold in our part of the world, not to speak of the Indian gold, obtained from ants, or the gold dug up by griffins in Scythia, is obtained in 3 ways. In the detritus of rivers, for instance in the Tagus in Spain, the Po in Italy, the Maritsa, Hebrus, in Thrace, the Sarabat, Pactolus, in Asia Minor, and the Ganges in India. And there is no gold that is in a more perfect state, as it is thoroughly polished by the mere friction of the current. Another method is by sinking shafts, or it is sought for in the fallen debris of mountains. Each of these methods must be described. People seeking for gold begin by getting up, searching for segulum, that is the name for earth that indicates the presence of gold. Beneath this is a pocket of sand, which is washed, and from the sediment left an estimate of the vein is made. Sometimes by a rare piece of luck a pocket is found immediately on the surface of the earth, as occurred recently in Dalmatia, when Nero was emperor, one yielding 50 pounds weight of gold a day. Gold found in this way in the surface crust is called tellurium. If there is also auriferous earth underneath the otherwise dry, barren mountains of the Spanish provinces, which produce nothing else whatever is forced into fertility in regard to this commodity, gold dug up from shafts is called channeled or trenched gold. It is found sticking to the grit, gang, of marble, not in the way in which it gleams in the lapis lazuli of the East and the stone of Thebes and other precious stones, but sparkling in the folds of the marble. These channels of veins wander to and fro along the sides of the shafts. The third method will have outdone the achievements of the giants. By means of galleries driven for long distances, the mountains are mined by the light of lamps. In a following passage, Pliny deals with the constitution of gold. In the translation by Rachman, 1968, page 53, we read, "All gold contains silver in various proportions. A tenth part in some cases, an eighth in others, in one mine only. That of Calaetia, called the Albuquerque mine, the proportion of silver found is 1/36, and consequently this one is more valuable than all the others. Wherever the proportion of silver is 1/5, the ore is called electrum. Grains of this are found in channeled gold." The reference to the Indian gold, ants and the Scythian griffins comes from Herodotus and is a tale spun through the ages down to the present day, being repeated and analyzed by Strabo and Pliny and by T.A. Rickard as late as 1930. Adams, 1938, discusses the probable origin of the tale in detail. "My personal opinion is that in ancient times someone found alluvial gold particles in termite mounds somewhere in Asia, from whence sprung the fable of the gold-digging ants. In this respect, it was well known by the old prospectors that ants would collect splendid particles of metals and minerals such as gold and galena. Some birds have a similar penchant. The griffin tale from Scythia may be similarly based on the circumstance that the spoil near certain animal burrows, e.g., marmot, in auriferous regions may contain particles of gold. The material called segulum or sigillum in some Latin versions should probably be translated as gossin segulo is still used by Castilian, Spanish prospectors to define the gossinous material capping certain auriferous deposits. I can find no translation for the Latin word tellutium or talutatium in some versions. I suspect that nuggety or alluvial was meant. The use of marble for the gang of gold veins is evidently an error. Quartz was obviously meant. The use of marble for the gang of gold veins is evidently an error. Quartz was obviously meant. Channeled gold in the second excerpt should be translated as vein gold. In a later passage, Pliny deals with the oxidation processes of copper minerals in gold veins. In the translation given by Bailey, 1929, pt. 1, page 105, it is stated, "Chrysocolla is an exudation found in the shafts, which we have already mentioned. It oozes down the vein of gold, and its muddy substance is congealed under the influence of the winter cold until it is as hard as pumice. It is well established that the best quality forms in copper mines, and the next best in silver mines. It occurs in lead mines also, but this kind is inferior to that found in gold mines. In all these mines, however, it is also prepared artificially, though its worth is far below that of the natural product, by leading a gentle stream of water into the vein all through the winter until the month of June, and evaporating the extract in June and July. It is therefore perfectly clear that chrysocolla is none other than a decomposition product of a vein of metal. There has been considerable discussion by classic scholars about the identity of chrysocolla. The modern chrysocolla is a copper silicate, and Pliny may have meant this mineral. In some cases, more generally, however, the mineral in question was probably malachite or azurite, the green and blue copper carbonates. The reference to the precipitation mechanism as due to winter cold follows from the ancient idea that many minerals were congealed, frozen, from water analogous to the formation of ice. This passage is one of the first references in the geological literature to oxidation phenomena in mineral, gold, deposits. The last of the classical Roman writers to briefly refer to gold deposits was Seneca, AD 3-65, contemporary of Pliny and tutor to Nero. In his Quaestiones Naturales he says in an interpretive translation, "In the earth there are some kinds of moisture that harden when fully formed. From these arise all metalliferous deposits from which our avarice seeks gold and silver." This passage suggests that Seneca followed Theophrastus in his view of the origin of gold deposits from water. Early Indian, Hindu manuscripts mention gold in many contexts, but deal only in the simplest of generalities with the origin of the various types of deposits from which the precious metal was obtained. The Rig Veda, first of the books of the sacred Sanskrit scriptures of the Hindus, composed about 1500 BC, contains several references to gold and silver, but gives only the barest details about the geology of the metals. In the Arthashastra of Chanakya or Kautilya, 4th century BC, There are further details about gold and silver, but these are concerned principally with the mining, metallurgy, and testing of the two metals. Mention is made, however, of the occurrence of gold ores in mountains and of the different types of auriferous ores. Unmixed yellow, probably pyritic ore, red and reddish yellow, limonitic ore, and some with a bluish color on fractures. Oxidized copper sulfide ore, nodules, nuggets, and needles of gold are also described from placers. Several color types of gold are mentioned. That with a blue shade, silvery, electrum, thorn apple-like, red, and pure, the color of the pollen of the lotus. The early Indian peoples mined gold extensively from bedrock deposits and obtained the metal from placers in many of the rivers of the Indian peninsula. Mining of the bedrock deposits was carried out principally in the oxidized zones of auriferous veins, and disseminations in sheared zones and iron formations. As is evident from very ancient workings in the famous Kolar field in South India. Some of these workings probably provided gold to the early Indus Valley civilization of 4000–3000 BC. Ray, 1948, Alchin, 1962, has reviewed the evidence of early gold mining in India and the methods employed in winning the precious metal. He has concluded from archaeological evidence and C14 dating that placer mining in India was widespread long before the Christian era, and that large-scale bedrock mining, principally in the oxidized zones, but also in some cases in the hard rock, in southern India began with the Mauryan colonization of the Deccan about the end of the 4th century BC. The Huddy and Kolar fields appear to have been first prospected and mined about the beginning of the Christian era. Therefore, Greek, Roman, and Indian writers provide little if any observational detail on geological and geochemical processes. Their knowledge of minerals was limited to only a few species, and their familiarity with rocks was essentially negligible. Therefore, they could not have logically evolved any systematic theories for the origin of gold veins and other types of deposits. Natural phenomena interested the Greeks, but their philosophers were concerned more with speculations on the great manifestations of nature rather than with mundane things such as gold veins. Another factor, it is said, revolves about the use of slaves in Greek, Roman, and Indian mining ventures. To engage in the earthy tasks of mining and geology was deemed to be below the elite and generally considered to be disparaging of one's station in life. It seems strange that the Greeks, Romans, and Indians never developed any precise scientific theories on the origin of gold and other types of deposits, despite the fact that gold was mined from its principal deposits, excluding the quartz pebble conglomerates, throughout their empires for many centuries. It has been said that the Roman in general, and the Roman mining engineer in particular, was a very practical man and not given to speculation and theories. The same can be said of the Greek, but only in part. Natural phenomena interested the Greeks, but their philosophers were concerned more with speculations on the great manifestations of nature rather than with mundane things such as gold veins. Another factor, it is said, revolves about the use of slaves in Greek, Roman, and Indian mining ventures. To engage in the earthy tasks of mining and geology was deemed to be below the elite and generally considered to be disparaging of one's station in life. Therefore, Greek, Roman, and Indian writers provide little if any observational detail on geological and geochemical processes. Their knowledge of minerals was limited to only a few species, and their familiarity with rocks was essentially negligible. Therefore, they could not have logically evolved any systematic theories for the origin of gold veins and other types of deposits. Thanks for watching.